PDE, and if you remember last time I said that there are two ways to solve this kind of problem, right? So one is the direct method and another one is Gaussian iteration. So basically, sorry, basically we are using the same equation. So in case of direct method, we are not, the reshuffling it, this equation, we just keep the equation as it is. So we will have, if you have number of, here we have 12 unknowns, so you will have 12 equations, okay? So we can solve this equation using any of the method that you know, that you have learned throughout this system of simultaneous equation, okay? So example 10.2 is explaining about the Gaussian iteration. So in case of iteration, you know that we have to put like the equation like x1 is equal to how much, y2 is equal, x2 is equal to, what is the equation? I mean the expression for x1, x2, x3. So here we do the same. We just change the equation, right? We just change this equation, and in this case we have this form, the same equation, but we try to express in this form. So we have y11, t11, 1, 2, 1, 3. So we have direct calculations, okay? And this is iteration. So initially we consider, if the values are not available, we consider as 0, and we always use the latest available value. So please spend some time, you will understand what I am going to say here, or what I said that. So this is the iteration technique. So if you do the iteration for a couple of times, you will get the refined results. Okay, anyway. So next is the parabolic equation, okay? So in case of parabolic, if you remember the expression, so the b square minus 4ac b square minus 4ac should be, in this case, is 0, okay? So this is the equation, and in this case it should be 0. You can compare it, this is actually 0. So if you have these kinds of equations, so we can solve this, okay? And one is the explicit way, another one is implicit way. Okay, so explicit means you can get the solution instantly, okay? Instant solution. And implicit means you have to solve some problem. I mean, you have to solve the expressions. So if you see del square t by del square, so this is the problem that I haven't mentioned this one. This is the problem for heat transfer or heat conduction. So we have this heat conduction equation, and alpha, in your project you can see that I asked you to calculate alpha and lambda. So alpha is what? So you have to spend some time to understand that what is alpha and what is lambda, okay? You can get the information also from here. Okay, so these are the all explanations, okay? So how we can solve. So this is the elliptical one. Some examples is also there. Last time what I said, okay, one more thing that I want to say. This one, when you have this equation, so it's elliptical PDE, sometimes the values are given directly, sometimes the values are not given directly. For an example, what I want to say here, I'll just refer back to again the previous problem, okay? So in this problem, they already said that the boundary temperatures are maybe some values, right? So the temperatures are like this. It says that this one 75, 300, 100, and 50. So the values are given directly. Sometimes the values are not given directly. Sometimes these are given in terms of expression. Okay. So it means that you change the value of x and you consider the 0, the time 0, or the y is 0. It means which direction is this? This is the lower boundary, right? So y is 0 means that you don't have the the y is 0, so x. So you have this, the value changes along the x direction. So this is the lower boundary. And in the lower boundary expression, how that value will change? X multiplied by x minus 1. Okay, it's not constant. So for different points, you will have different values. So if you consider this one is 1, 0 to 1, and if you consider 1/3, 1/3, So you need to put x is equal to 1/3. Okay. So it should be 1/3 and then multiplied by 1/3 minus 1. So it means that in short, okay, you can spend more time on that. So in short, that the expressions, the values might not be constant. It could be given in terms of some expression. So you just put the values and you will get the result. Okay, I mean you will get the value of u at particular nodes. So here also. So 0 and 1. So in this case, when your value is 0 and y and 1 and y, so all values are 0. So this is a constant. Okay. So along which boundary is this one? This one is left boundary and this one is the right boundary, right? So x is 0 and y will change. So this one is the boundary left one and 1 y is means right boundary. And this one is x1. So in this case, 1, y is 1. So it is the upper boundary. Okay. So all the values are given. So once you know the values, okay, so like this, then you can create nodes as they say that. So the red values are already known. You just don't know about the black values. So just apply the formula and you will get the results. In this case, it's 4 unknown. You will get 4 equations. If you use the direct method, you have to solve 4 first order simultaneous linear equation. And if you consider the Gauss-Seidel iterations, you can solve the problem directly. So you will have only 4 unknowns. Okay. So so I go to the this part. So there are 2 problems. Okay, so just try to solve the problem from the slide, and for the explanations you can rely on the book. Okay, so maybe the slide explained a lot, so you might be maybe superficial or maybe you might be confused. Okay. Anyway, if you are interested, you can go on that. So no problem. So now I go to the elliptical. Elliptical already says, sorry, is parabolic. Okay. So what I said that parabolic has two ways to solve. One is explicit method, another one is implicit method. For explicit method, so we use the heat transfer equation. There are some constants alpha, so I'm not focusing on that. We have del square t by del x square and del t by del t. So this one is a change in the temperature with respect to time, and this one is a change in the temperature with respect to x. So you have 2 independent variables. Another one is time, another one is x. Okay. It means that if you have this one, if you have a rod, so your value, the t value will change along the x direction, and also the value will change with respect to the time. So at time t0, you will have one value. At time t is equal to 1, you will have different values. Okay. So you have 2 variables in this case, x and t. So sometimes the variable is xy, sometimes the variable is xt, sometimes the variable is yt. Variable means I mean the independent variable. So you have to detect that the variable, which one is dependent, which one is independent. So you can have the clear knowledge that, okay, your time is changing with respect, sorry, the temperature is changing with respect to position and also with the time. Okay. So what you can do here, so here when we consider the explicit method, so we use the center difference. Okay. So we use the forward difference method. Sorry, we use the forward difference method. You have to understand. Okay. So del t by del t, small t, temperature. So this one, you can see that the I is actually representing x and j is representing the time. So your derivative is with respect to time. So your I will be fixed and j will change. So it means one step. So at the same position, so the future prediction minus at the same position normal values, okay, or current value. It means j plus 1 minus j, tij. So I and j, you have to understand, okay, which one you will change. You will change I or you will change j. So it depends on the with respect to what is with respect to time means in this case you need to change j because I represent in this case the location x. So you have this one, okay. So and another one is del square t. So you have this again the center order, second order, okay. So you have to use this one, the second order derivative, in this case central derivative. Okay, so we use the central second order derivative. You have to understand and you remember these things. This one is with respect to x, so j will not change. So it's one step ahead, minus 2 minus current step plus 1 step behind. Okay, so you have these 2 expressions. So you put the values there, and in this case is like this. Okay, so alpha, this one is equal to this, and then to remember that you have to I'm sorry, when you want to derive the explicit information, so you have to express the formula in this way: t j I j plus 1. It means your future value is depending on your current value. Remember, The formation is your future value. I is the position x. J plus 1 is the time. Okay, so it means that your future prediction will be depend on. You can see I, j, 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 j. It means it of course depends on the different position, but is always j. It means j plus 1. The future value is depending on the time. It's very very important to remember. Okay, you have to explain your expression should be future value should be equal to in terms of current value. You have to explain in this way. So now you can see that your future you can predict with respect to the current value you already know. Okay, so it means that using this method you can get the value directly. So here in this case alpha delta by del x square, this one is actually constant and we call this lambda. So in the project you can see that I already asked you to calculate alpha and lambda. So this is the alpha, this is the lambda, you have to understand. Okay, so if you calculate only the lambda, so you can simplify it. This one future value is equal to this j plus lambda multiplied by this one. Okay, so if you have this information, now you try to solve the problem. So this is the type of problem that almost similar to your project that I say. So the value k, lambda, c all are given. Okay, so you can just have a look. It's nothing too big deal to deal with these things. So your alpha already you know what is alpha. K by this one is a solution. So you can use this expression for your project also. This will be the same expressions. Okay. So and then the lambda will be this value. So if you already deal with the alpha and lambda, then you have to find out the time steps. Okay, so here you can see the rod of steel shown in the figure, in this case here, I think. So this one is subject to a temperature 100 on the left hand side and 25 on the right hand side. If the rod is of length 0.05 meter, use the explicit method to find the temperature distribution. Distribution means how the T change with the X. It means you have to find out the time, the temperature at different position. And also not position actually, it means you have to find out the distribution from T is equal to 0 to T is equal to 9. It means the change in the temperature with respect to time. Okay, and how about this internal node? It said that del x is equal to 0.05, so you 0.1, so right. So your total length is 0.05, so it's 0.01, 0.2, 0.3, 0.4, and 0.5. So you already know that, and the time is t second. It means you start from 0, then 3, then 6, then 9. Okay, so all the values are given here. And here the initial temperature of the rod is 20 degree. Initial temperature of the rod means the value here when time t is equal to 0, so all the values are 20. Okay, then the value of 20 will not be consistent, then that it will start to change with respect to time. Okay, so in this case, your values. Okay, so this one already know, this one you already know. It means that how I can say that t00, then you have 10, 20, 30, 40, 50. Okay, so these values are 0. So it depends on 0 and 5. So 101, I mean 0, 0 and 01, 02, 03. You have to find it like this. The initial conditions at time 0, all time 0 initial, but the position different value, right? So the left boundary is 100, internal are 20, 20, 20, 20, and the 5, I mean this node is 25, already given. So these are the initial condition. Now you try to find it out. So you need to calculate 1, 1, right? So if you want to calculate T11, you go to the formula, how you can find it out. You need to put I is equal to 1, J is equal to 0, right? Then you will get 1, 1. So you do the same thing here. You just put 0, J is equal to 0, I is equal to 1. So in this case, 0, 1 is already conditioned. So 1, 1 will be this equation. So you can see 10 you already know, 20 you already know, 10, 200, all values are you know. So you can get the T11 directly, explicitly, that means like instantly. Okay, so same way you just consider T, you need a second x position, and after the time T 1 second, right? I mean the next step is 3, but in this case 2, 1 should be the initial value plus this is the equations. Okay, so all the values are known. Okay, so it means that if you consider that because you are predicting the future with respect to the current values are already known to you, so you can calculate in this way. So this is all the values is after t is equal to 3 seconds, right? Then you have to consider this one and predict the next one. So that should be 0, 2. Okay, so you have to use these values here to predict the next one. So you have to repeat the same thing. It's easy. Okay, so and you will get this one is 0, 3 means the same position but after 9 seconds. Okay, so you will have these distributed values. So if you change this one, plot it for different locations, t is equal to 3, 6, and 9, you will get this result. So this is the explicit method. Okay. And next thing is we need to consider the implicit. So this is another way to solve the problem. Why we need that? Okay, why we need the implicit method? Because it said that if you try to solve the problem PDE using implicit method, there is a question regarding the stability. Okay, so you know the value of alpha, lambda, and alpha. So this value is actually should be less than half. Okay, if you want to consider the explicit method in order to ensure the convergence and stable situation, or to consider the stability of the system, you must have this product value less than or equal to half. Okay, so sometimes it's very difficult to consider this del t and del x combination so that the product, the alpha del t by del x square is less than half. So in that case, we cannot use explicit method. So we have to rely on implicit method. Okay. So what is implicit method? In case of implicit method, what we try to do, so if you remember, in case of explicit, we try to predict the future with respect to the current value. So in this case, we do the opposite. Okay, so we want to our expression in this way, we try to generate the expression the current, the future is depends on the current. Okay, so if you can see here, del square t by del x square. So before we use ij, if you remember, we use ij. Of course, you can go back and have a look. What is the difference between these two? So I go back, and here you can say ij. Okay, then we consider this one, and also here ij. But when we consider the implicit method, because we will not get the solution directly, we have to solve the equations to get the solution. So in that case, when we build up the general equation, we consider not tij, we consider ij plus 1. Okay, we consider the future values. Where I missed up. Okay. Yeah. So this is ij plus 1. Then you just apply the formula. This is with respect to x. So j plus 1, j plus 1, j plus, it will be not affected. Okay. And when we consider this one, j plus 1, so we consider is a divided difference. Okay, backward. We consider the backward difference, not the forward. Okay. So before we use the different equations. So in this case, we need to consider the backward divided difference method. So we have this one, so we need to consider the forward. So we actually link up future with the present. Okay, before we consider the present, link up with the future. It's just opposite. So here we all have the future values. So if you have these things, so then just put the values like this, like before, and then you rearrange the equation. Your expression will be like this: Tij. It means the current depends on the future. So before, if you compare like before, it was that future depends on the current, but in this case, it's just opposite. Your current depends on the future. So your left hand side or right hand side, whatever it is. So alone variable is actually before. In case of explicit, it was future value Tij plus 1, but in case of implicit is Tij. Okay, that is the difference. So what will happen if you use this one? You can use the same, exactly same situation, same problem, but just you need to justify these things, right? So when you need to find out the Tij. In this case, just put the value. In this case, is a 0, 1, 0, right? Because you know the value which one you have, because this is a present value. So you have to consider 1, 0, 2, 0, 3, 0, 4, 0, and these are the values. So before is different, because now we focus on, because we need to relate the current with the future. So your current is the right hand side. The single variable, the term that you have is ij, right? So in this case, I need to 1 and j should be 0. So if you have this one, because this value you already know, and these values lambda you already know, some values you already know, and some you don't know. Okay, so you have this expression then, because 1 1 2 1 you don't know. This one you know, 0 1. Okay, so this one is the initial values, boundary condition, I mean the left boundary. So you have this expression because 1 1 2 1 you don't know, so you cannot get the solution. So same way you will have 1 2 3 4 equations. Okay, so if you have 4 equations, of course you have the matrix form, then you have to solve this problem to get the solution. Okay, you cannot get the solution directly, as you expect, in case of explicit method. So that is the difference between implicit and explicit. In explicit, you get the solution directly because we consider the future depends on the past, and the past, the future depends on the present, and present value you already know. Okay, so the future should be equal to, you just multiply something with the present value, you will get the result directly. But in this case, we relate the opposite. We relate the present depends on the future. So the future depends on the present, future depends on the present. So then we have some, because the future we all know, don't know those things. So you have to know the future in order to relate the future with the present. So that's why we need to solve matrix here. There is a simple difference that makes the situation different. But in this case, we no need to think about the stability. So that's why we prefer to use implicit formulas. Okay, so maybe in the project I said that you can have a look later on. So most of you need to solve this problem in this way, but you need to write the codes. Okay, but anyway, it's not a difficult task. It's just node definitions and just initialize the value and just write the problem. And the results are already in the book, as I can show you here later on. Program is also written, but you have to understand the things. Okay. So these are the things. Is it another problem? Oh, this is just, you got the one step ahead, right? So you have to do the same thing for 3 times, because your the time is 0, then 3, 6, and after that 9. Okay, so you will get these things. You have to solve a lot of equations. So 3 times you have to solve, then you will get the solution, and you can plot it. Actually, the plot looks like same, like implicit and explicit. But as I said, that you will need the implicit method when there is a problem regarding the stability. Okay, so stability means you have to tune the alpha, del t, and del x squared, so in such a way that the value should be less than 0.5. So this is the case for hyperbolic, what I said that parabolic PDE, then where we discuss the implicit and explicit method. So here they use the same, but as I said, they try to relate the relationships. If you don't want to go through in detail, that's okay. Just you have to solve the problems in your project. So that should be okay, because you don't have the assessment on that later on. But you have to understand the basics. So I don't want to explain all the things here, because you might be superficial, like what are the things. But if you just focus on the book and try to understand the problem from the book, that would be enough. Okay, because these slides gives you lots of information, so I don't want to explain in details thoroughly. But in the video also, I try to explain the method so that you can understand. Okay, and nothing to be worried. Okay, so anyway, so I just continue the last part. Is there any question? No questions. Is it okay? Okay, so I will explain the last part of your numerical method. Okay, so that will be the end. But the end doesn't mean that I don't have class. So we will focus later on. We will discuss the things that we have learned. I will share the marks with you. Okay, so we will discuss on those things later on. So why I'm hurrying up to finish this one, so that you can get enough time to finish your project. Otherwise, because it's already, as I said, maybe you can check the e-learning. Maybe I give the time, maybe 2 weeks. So you must write the program. Okay, so hyperbolic PDE. Although this one is not included in your project. I'm sorry, I have all the mails and those stuff, so distracting me. Anyway, so hyperbolic PDE, if you remember last time, it should be less than 0. So anyway, I go here to the book again. So in this case, you see there's the expression. Okay, so maybe wave equation, Poisson equation. These are actually the expression or equations for hyperbolic. And we have the same thing. We have the boundaries, right? C is the coefficient. Of course, the value will be given to you. And these are the boundaries, 0, 2. So in this case, what are the dependent and independent variable? You can see U depends on X and T. So it's actually velocity depends on the position and the time. Okay, so your X and T you have to keep in mind. And so first one is the X, so it means the left boundary, and this one is the right one. And this, so this is actually depends on L, and these are the same. Okay, so and initial values, these values are given. Okay, hold on 1 minute. Just give me 5 minutes break. Okay. I was having some emergencies. Okay. So I was talking about the hyperbolic equation, right? So here you can see, hold on 1 minute. Okay, so with the boundaries is this the problem you have to solve, and the boundaries are already given like this. So as I said that there are two independent variable X and T. So this value X is equal to 0, and with the time T, it means the left boundary is like this, 0, and in this case the right boundary is also 0. The initial condition X and 0 times 0, it means this along the lower line you have the values, okay, and the value will change with respect to like this 1 over 8 sine X. Okay, so you have different values. It means 0, 0, then 1, 0, 2, 0, 3, 0, 4, 0. You can see the values that they calculated using this one. Okay. On the other hand, you have these are the values, and del U by del X. It means like the velocity in this case is not used. So you have the left side, right hand side, and lower side. And by using the finite difference method, okay, so to use the finite difference method, you have to take X is equal to 0, and then 0.2, 0.8. It means 0.2, 0.4, 0.6, 0.8, and 1. Okay, and the time is T 0, 0.1, 0.2 only. All the calculations are in 4 decimal points. So here, initially, you need to find out what is the age in this case. So x naught is 0, 0.2, 0.4, 0.6, 0.8, and 1. And the time along the t direction should be 0. And then we have the 0.1 and 0.2. Okay, so we have the grid like this. For this grid, 0, 0, 1, 0, 2, 0, 0, and then 0, 1, and 0, 2 already given. 0, 5, 0, and then 5, 1, 5, 2 already given. All are 0, right? And then we have all the values along the h, lower h, 0, 0, 1, 0, 2, 0, 3, 0, 5, 4, 0, and 5, 0. And given this condition is given, here it said that velocity at x0, it means in this case the velocity here at the time 0 along the x in this direction, the lower boundary, so velocity is given as 0. Okay, so it means, what does it mean? So in this case, we just use a central difference formula. So we will have ui1 and ui minus 1 divided by 2k is equal to 0. Okay, so we have this formula here. So if you have the velocity, something is given, you have to simplify the boundary condition. You have to simplify the boundary condition or the given condition. So derivative, just consider the central difference method. So this is should be I1 and then I minus 1, okay? So in that case, you have 2H. So I hope you understand. So we apply here 0, 0, so 1, and this one is minus 1, okay? So this should be along the x direction, so x will not change. So we have the change with respect to the time, okay? So you have to remember that one. So we have this minus 1. In this case, then we can simplify it. So this should be equal to this one. And if you apply the same formula for, in this case, this formula is for x0, right? So we have different x. So this means that xi. So in this case, we have different point, okay? Here, and here. This is the x. And the time derivative is with respect to t, you have to change it. So this formula, this boundary condition can be simplified in this way. In this case, x0 minus 1 is 1. Then x is equal to 1 minus 1 is equal to 1. Then 2 minus 1 should be 1. 3 minus 1 should be 1. And 4 minus 1 should be 1. And 5 minus 1 should be 1. So this relationship, we will use it to simplify it. If you remember last time what I said, that we could have the fictitious point, okay? When we deal with the second order derivative, we could have fictitious point. Last time when I explained the PVP, that time I explained, okay? So this is the same similar type of condition, because when we have the second derivative and you apply the formula, so this is the formula that we apply, the second order central difference formula for this and this, and this one just simplify it. So you need to express the form in this way, uij plus 1, okay? So this one is I, in this case x, and then future value is the same. So you are in situation with x and you predict the future with respect to present and the past. So because it's a second order, you have j minus 1. Okay, so generalized formula, they just put the values here, all the r and k's, h and k value already they've substitute, and at last they will have this expression, generalized expression. And then they try to calculate, okay? So they will try to calculate this 1, 1, 2, 1. Just put the value of 1, 0, 2, 0, 3, 0, 4, 0. Again 1, 1, 2, 1. Okay, 3, 1, 4, 1. So if you have this one, and here you can get the solution directly, because again your value, your future value depends on the present, okay? So remember that this one is present, this is one step ahead, okay? So but j is the present, all the values j, j, j. It means the values depends, the future value depends on the current value. It means that using this hyperbolic PDE, you can get the solution directly, because all are initial values, okay? You can get this one, 2, 1 should be like this. So this one shot, just keep this, substitute this formula to the right hand side, and you will get the result directly. You no need to solve the problems like in implicit method, because in this case also the same thing is your future depends on the present. So what is the small difference here we have? So here the difference is this one. You can see sometimes you need to, if you have 0 minus 1, you have to substitute it with 0 1, because actually we don't have 0 minus 1, we don't have minus 1 grid, right? We don't have the past value. So the 0 means the current situation. Here we don't have 0 minus 1, we have 0 0, we have 0 1. So the past is actually the future, because the derivative at this point is 0. Okay, so that is the things that you have to use. If you got some negative, I mean the past value, you have to replace it with the present one. So here you have the past value, right? You have to represent it in terms of present one. So here the represent is 1 1. Sorry. So you have to consider this one. You have to give some time, little bit, but it's not that difficult. It's straightforward. But just remember how we relate the future with the past, past with the future. So this is actually more or less is mostly is similar to the implicit method. Okay. So that's the thing that you have to solve. So this is the problem that I give you in your project. But of course the values are different. Say metal rod of length, in this case it said it's 0.1 as shows here. The initial temperature is 70. Initially it was 70 degree, and that is the temperature at all the nodes inside the rod. Okay, so within all the nodes 0 you will have these values, and then your left hand side and right hand side is different, 50 and 20. then you have to use the implicit method to find the temperature distribution of the rod. Implicit method means you already know that you have to use the method that I just explained. You have to solve the system of linear equations, right? So after these are all the values are given, so you have to find out the alpha and lambda. This one you already know, and you also need to solve this problem using direct method and Gaussian iteration. So same problem you can solve it that I explained in ellipse. Okay, so you can solve the same problem using that direct method. It means just solve the problems using the iteration technique or direct method. Sorry, so you have to solve the system of linear equation, and you can in that case you can use a Gauss-Seidel iteration. So is another one. So actually it's three problems you have to solve using implicit method, another one is direct method, another one is Gauss-Seidel method. Okay, so same problem you will solve and then try to compare. So normally all the codes are here, okay, and you have to repeat the code for delta t is 1 second and delta 2 is 2 seconds. Okay, so that's the thing. And how many you need to consider until 10. So because that's why I asked the students to make the program, because it's impossible to solve. Impossible means it takes lots of time. Okay, so just you consider del t and make the program, and it will solve the problem until 10 seconds, 20 seconds, it doesn't matter. It will take maybe less than few seconds. Okay, maybe 10 seconds. Within 10 seconds, the system can calculate. So they use some sigmoid functions, so some part. So you have to understand those things, or you can develop your own code. No need to follow, because the same problem can be solved in different ways. So if you can solve in your way, should be okay, no problem. As far as you get the result and the result is accurate, so it doesn't matter. Okay, so all the references I try to scan and upload it for you. Is there anything you want to say? Remember that you will have the class test, right? Class test 2. So for being, just try to focus on the class test. Okay, just after the class test, you focus on the project, okay? And then finish it up. So I will meet with you next week. I will discuss with in the group, okay? So when we can meet, and then we will try to disclose the marks and how you perform in this course. Okay, so that will be enough, because we don't have any final exam. Okay, so that's all from me here. If you do you have any questions or just anything you want to ask regarding the class test? Already I mentioned a lot of things. Okay, so please try to solve the problems. I hope you this time you will get good marks if you can solve the problem properly. Okay, so please practice. Okay, don't try to this plan that it is very simple and I will solve this during the exam time. That will be difficult for you. Anyway, so I try to share the attendance here again. Section 3. Same problem. Okay, so I share the section 4. Anyone left in section 4? So others can leave, no problem. All the best for your class test.
Yes, sir.
Thank you. Bye.